In this method of solving systems of equations by elimination, we eliminate one of the two variables in each equation by using addition. First, we must see to it that the terms in both equations are aligned. That is, the x terms are in one column, the y terms are in one column, and the constant terms are also in one column. Let us do example number 1. In this example, the x terms are already in one column, the y terms are already in one column, and the constant terms are already in one column. Let us eliminate by addition. The first equation of the given system of equations is 3x plus 2y is equal to 4. The second equation is 4x minus 2y is equal to 10. 3x plus 4x is equal to 7x. Notice that the numerical coefficient of y in the first equation and the numerical coefficient of y in the second equation are numerically equal but opposite in signs. So positive 2y, negative 2y is equal to 0. So positive 2y and negative 2y are eliminated. 4 plus 10 is 14. Divide both sides by 7. So x is equal to 2. Next, substitute 2 for x in either of the two original equations, then solve for y. Let us choose the first equation. 3x plus 2y is equal to 4. Substituting 2 for x in this equation, we get 3 times 2 plus 2y is equal to 4. This is equal to 6 plus 2y is equal to 4. Transpose 6 to the right side. Change its sign from positive to negative. This is now equal to 2y is equal to 4 minus 6. 2y is equal to negative 2. Divide both sides by 2. Y is equal to negative 1. If we substituted 2 for x in the second equation, we will also get y is equal to negative 1. The solution is 2 comma negative 1. 2 here is the value of x and negative 1 is the value of y. Let us check. The first equation in the given system of equations is 3x plus 2y is equal to 4. The second equation is 4x minus 2y is equal to 10. The solution we got is 2 comma negative 1. 2 is the value of x and negative 1 is the value of y. To check, just substitute 2 for x in the first equation and negative 1 for y also in the first equation. The first equation is 3x plus 2y is equal to 4. So this is now equal to 3 times 2 plus 2 times negative 1 is equal to 4. This is now 6 plus negative 2 is equal to 4. 4 is equal to 4. This is a true numerical statement. Next, substitute 2 for x in the second equation and negative 1 for y also in the second equation. The second equation is 4x minus 2y is equal to 10. This is now equal to 4 times 2 minus 2 times negative 1 is equal to 10. This is now equal to 8 plus 2 is equal to 10. 10 is equal to 10. This is a true numerical statement. This means that the value of x is really equal to 2 and the value of y is really equal to negative 1. Example number 2. The first equation of the given system of equations is 4x minus 5y is equal to 2, and the second equation is 4x minus 3y is equal to 6. The x terms are already vertically aligned. That is, they are already in one column, and the y terms are already in one column. The constant terms are already in one column. So the first equation of the given system of equations is 4x minus 5y is equal to 2. The second equation is 4x minus 3y is equal to 6. If the coefficients of one of the variables are equal, multiply both sides of one of the equations by negative 1. You can multiply the first equation by negative 1 or you can multiply the second equation by negative 1. Let us multiply the second equation by negative 1. So, the first equation remains the same. 4x minus 5y is equal to 2. And then, the second equation becomes negative 4x positive 3y is equal to negative 6. That is negative 1 times 4x is negative 4x. Negative 1 times negative 3y is positive 3y. Negative 1 times 6 is negative 6. Then add 4x plus negative 4x is equal to 0. So 4x and negative 4x are eliminated. Negative 5y plus 3y is equal to negative 2y, and 2 plus negative 6 is negative 4. So we have negative 2y is equal to negative 4. Divide both sides by negative 2. So y is equal to 2. Next, substitute 2 for y in either of the two original equations, then solve for x. Let us choose the first equation. 4x minus 5y is equal to 2. Substituting 2 for y in this equation, we get 4x minus 5 times 2 is equal to 2. This is now equal to 4x minus 10 is equal to 2. Transpose negative 10 to the right side. Change its sign from negative to positive. So we have now 4x is equal to 2 plus 10. This is now equal to 4x is equal to 12. Divide both sides by 4. X is equal to 3. If we substituted 2 for y in the second equation, we will also get x is equal to 3. The solution is 3, 2. 3 here is the value of x and 2 is the value of y. Let us check. The first equation in the given system of equations is 4x minus 5y is equal to 2. The second equation is 4x minus 3y is equal to 6. The solution we got is 3, 2. 3 is the value of x, 2 is the value of y. To check, just substitute 3 for x in the first equation and 2 for y also in the first equation. The first equation is 4x minus 5y is equal to 2. So we have now 4 times 3 minus 5 times 2 is equal to 2. 12 minus 10 is equal to 2. 2 is equal to 2. This is a true numerical statement. Then, substitute 3 for x in the second equation and 2 for y also in the second equation. The second equation is 4x minus 3y is equal to 6. So this is now equal to 4 times 3 minus 3 times 2 is equal to 6. 12 minus 6 is equal to 6. 6 is equal to 6. This is a true numerical statement. This means the value of x is really equal to 3 and the value of y is really equal to 2. Example number 3. The first equation in the given system of equations is 2x minus 3y is equal to 2. The second equation is 3x minus 4y is equal to 4. It is sometimes necessary to multiply both equations by a non-zero real number other than negative 1 in order to make the coefficients of one of the variables numerically the same but opposite in signs. In this example, if we multiply the first equation by 3 and the second equation by negative 2, the numerical coefficients of the x terms will be numerically equal but opposite in signs. Let us do that below. 3 times the quantity 2x minus 3y is equal to 2. 3 times 2x is 6x. 3 times negative 3y is negative 9y. 3 times 2 is 6. So we have 6x minus 9y is equal to 6. And then multiply the second equation by negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative 4y is positive 8y. Negative 2 times 4 is negative 8. So we have negative 6x plus 8y is equal to negative 8. Notice that the numerical coefficients of x in the first equation and in the second equation are numerically equal but opposite in signs. So 6x plus negative 6x is equal to 0. 6x and negative 6x are eliminated. Negative 9y plus 8y is equal to negative 1y. 6 plus negative 8 is equal to negative 2. Divide both sides by negative 1. So y is equal to 2. Next, substitute 2 for y in either of the two original equations, then solve for x. Let us choose the first equation, 2x minus 3y is equal to 2. Substituting 2 for y in this equation, we get 2x minus 3 times 2 is equal to 2. This is now equal to 2x minus 6 is equal to 2. Transpose negative 6 to the right side. Change its sign from negative to positive. This is now equal to 2x is equal to 2 plus 6. This is now equal to 2x is equal to 8. Divide both sides by 2. X is equal to 4. If we substituted 2 for y in the second equation, we will also get x is equal to 4. The solution is 4, 2. 4 is the value of x, 2 is the value of y. Let us check. The first equation in the given system of equations is 2x minus 3y is equal to 2. The second equation is 3x minus 4y is equal to 4. The solution we got is 4, 2. The value of x is 4 and the value of y is 2. To check, just substitute for 4x in the first equation and 2 for y also in the first equation. The first equation is 2x minus 3y is equal to 2. This is now equal to 2 times 4 minus 3 times 2 is equal to 2. This is now equal to 8 minus 6 is equal to 2. This is now 2 is equal to 2, which is a true numerical statement. Then, substitute 4 for x in the second equation and 2 for y also in the second equation. The second equation is 3x minus 4y is equal to 4. This is now equal to 3 times 4 minus 4 times 2 is equal to 4. This is equal to 12 minus 8 is equal to 4. This is now equal to 4 is equal to 4, which is a true numerical statement. This means the value of x is really equal to 4 and the value of y is really equal to 2.